All right, so
Call it illegal.
are we good? Are we good?
Yeah.
Okay. So today we are going to be so we're going to be verifying geometric sequences, just like we did with the arithmetic sequences, just saying if it is or not. And then we're also going to be finding the rules given different things. So let's do some definitions to start. So in a geometric sequence, the ratio of any term to the previous term is constant. So this time we're talking about a ratio, which if you see the word ratio, you should think fraction. This constant ratio is called the common ratio. Common ratio. And is denoted with R. So remember, we had the common difference for arithmetic sequences. Now we have a common ratio. For whatever reason, I gave you like no space for example 1. So we're going to squeeze it in here. These ones, you can still sort of see the pattern, but it's not as easy as like where we could just draw the arrows and see how much it increased or decreased by. So the setup for these, and again, sorry, write small. You're going to take the second, or like the next term divided by the previous term. So like A2 divided by A1 would be 10 over 4. If you reduce that, you end up with 5 over 2. And I'm going to circle it just so we know that that's our first ratio. Then the next one that I would compare would be my third term divided by my second term, which would be 18 over 10, which if we reduce that, we get 9 over 5. So are our common ratios the same? No, it's not a common ratio. And in math, you only need one counterexample and technically you're done. So my answer would be no, this is not geometric. And on Go Formative, it's just a yes, no. Oh, hey, yeah, my directions are wrong. That should say geometric. These notes are so similar to the arithmetic that I really just like went through and I like erased certain words. And apparently I missed one. All right, so part B, now we're comparing this one, and maybe you can see why this is going to be one, because spoiler alert, it will be one. So when we type this in, it would be A2 over A1, which is going to be 125, sorry. 125 over 625. I know you can probably do this simplification in your head, but I do want to show you something cool with your calculators. If you are feeling supremely lazy, because remember, we're in Honors Algebra 2 now, and so I trust that you can simplify fractions. So frankly, if you want to do it with your calculator, that's fine. What you can do is you can type 125 divided by 625, and it gives you this decimal. If you have a graphing calculator, you can hit this math button here. Your first option is this arrow frac, that stands for like fraction. If you hit enter, it's going to take your previous answer, which is the decimal, and it's going to turn it into a fraction that's reduced. And so it gives you that it's 1/5. So this is actually a thing your calculator can do. And since I know we all know how to reduce fractions, I am completely comfortable with you doing it that way. All right, so that was my A2 over A1. My next term is going to be A3 over A2, which would be 25 over 125, which reduces to 1/5. Then I have to do A4 over A3, which will be 5 over 25, which again reduces to 1/5. Then I totally run out of room here. My last one will be A5 over A4, which is 1/5. It's already reduced. So is this a geometric sequence? Sure is. So my answer would be yes. Any questions on how to verify? Okay. So I grabbed this from online from our book, but they didn't have a better printed one. So if yours is too blurry, this equation is completely correct, but it says the nth term of geometric sequence with first term A1 and common ratio R is given by, and then if you can't see your formula, I'm just crossing it off so we're not distracted, but it is correct, but it's A sub n. It's your first term, A1, times r, which is your common ratio, raised to the n minus 1. So if yours is kind of blurry, you can cross it off and rewrite it. But that's what it says. So this is the formula for when we're finding our rule. This is the thing that we're going to write down every time until we have it memorized, because your test and quiz, you will have to have these memorized. So example 2, much like when we did the arithmetic sequences, it is easiest if I give you just the sequence, because then all you have to do is find the common, for arithmetic was finding the common difference. Now really we just have to find that r, the common ratio, and then we already have our first term, so we're good to plug it in. So again, our general formula is a sub n equals our first term times r to the n minus 1. And the only thing I'm missing, I have my a sub 1, right? And I'm missing my r. So that's what I have to solve for here. And I can do that by taking any two terms. I don't have to take all of them, but any two should work. So I'll just take my a2 over my a1, which would be 20 over 4, which is 5. So 5 is my r. So my final actual rule is a sub n would be 4 times 5 raised to the n minus 1. For Go formative today, anytime you have like, so your exponent, you'll always want to have in parentheses, and then whatever's being raised, you'll want in parentheses. All right, so this is my rule, and then I have to find my 7th term. So just plug in a7 would be 4 times 5 to the 7 minus 1, which is the 6. So that'd be 4 times 5 to the 6, which is something, I didn't even do it. So 5 to the 6th is 15,625 times 4. So you should get that a7 is 625 or 62,500, excuse me. Anyone get anything different? Easy, right? All right, let's do one more just to make sure we're all on board. Part B, again, throw down that general rule so that we can memorize it faster. I have my A1. I know that this 152. I just need to find my R. So I'm going to take my A2 over A1, which would be negative 76 divided by 152. If you reduce this fraction, again, you can use that trick with your calculator. You should get negative 1/2. So that's my R. And I'll circle it so I don't lose it. So then my general rule would be 152 times negative 1/2 to the n minus 1. If I'm finding my 7th term, it would be 152 times negative 1/2 to the 7 minus 1, which is just 6. And I'm actually going to let my calculator handle all of this, because your calculator can do order of operations. So 152 times negative 1 over 2 raised to the 6th. Oh, and it even gives it to me as a fraction. That's so nice. So it's 19 over 8. Did anyone get anything different? Sweet. All right, so pretty straightforward. Any questions about example 1 or example 2? All right, let's look at some more interesting ones. So example 3, we want to write a rule given a term in the common difference. And then we're going to graph. I do have 2 on your homework that are graphing. So you'll find the rule and then you'll graph the sequence. So this one, notice I'm given my R, but I don't have my A1. I have A4. So the general rule is AN equals A1 times R to the n minus 1. And now I do have an R, but I don't have my A1. So like the other day, we're going to have to solve by plugging in A4 so that we have A1 times R. And then instead of n to the 1, it'd be 4 minus 1. We can go ahead and plug in for our A4 and R. A4 is 12. So I have 12 equals A1 times, my R is 2 to the 3rd. How would I solve for A1 here? what operation could I use to solve for A1? Divide. Yeah, I'm just going to divide it. I'm not even going to overthink it. I'll even leave it as a 2 to the third. So you can do 12 divided by 2 to the third, and you should get a decimal, which I'm betting this calculator won't give me one. Let's see. No, it did. Cool. And knows exactly what I want. 1.5. So that's my A1.
Do we keep it as a fraction or does it have to
It doesn't, frankly, I don't care. For this one, so in general, we want you to keep things as fractions, but when you're graphing, I think it makes more sense to have it as a decimal because, for example, I don't know, like 52 over 3, I don't have much sense of what number that is right away. I mean, I'm sure I could figure it out, but it's easier as a decimal to graph it. So I do generally tell students that if you're graphing something, decimals are better. So I guess that's what I'll say on that. I will want you to make a table. For today, in your table, you're going to put 1 through 6. So I want 6 terms in your table. But then I think there's at least one homework question where the 6th term is just huge. So you can skip graphing the 6th term on your homework. The other thing about this is yesterday when we did the arithmetic sequences and we graphed those, we really could just plug it in our head. Today, that might be a little trickier. Oh, I forgot to just write the rule. Let's start by writing our actual rule. It would be a sub n equals 1.5 times 2 to the n minus 1. There's my rule. So it's a little harder for me to like plug in 1 and know exactly what's happening here for my points. I am 1000% okay if you want to put this into your y equals, right? This is what we have calculators for. You've already been graded on like, doing functions in your head and stuff. So I'm fine with you just putting this in. So if you typed it in, it would be 1.5 in parentheses 2 raised to, and then another parentheses if you have the older calculator, x minus 1. And you can go second table, and there's our table of values. So this would be 1.5, 3, 6, 12, 24, and 48. For my scale today, we can just use these outer lines. So this is my n, and I'm going to count by ones on my n. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then for my a sub n, the y-axis, I'm going to count by 5s here. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. If you show your ticks and you show what your maximum is, I can figure out what you were counting by. Just make sure you put some kind of scale if you are counting by something other than 1. If you're counting by 1, you just don't put any units, and I can assume in that case. But otherwise, you should have units. So at 1, I'm at 1.5, which is kind of like sitting right there. At 2, I'm at 3. At 3, I'm at 6, so just above my 5. At 4, I'm at 12, so that's 10, 12 would be right about there. At 5, I'm at 24, so 5, 10, 15, 20, 25, just under 25. And then at 6, I'm just under 50. Do we want to connect our points? No. No, because this is a sequence that we're graphing. And if you connected your points with a line, that's implying that like something here, right here, is in your sequence, and it's not. So yesterday, the arithmetic sequence looked like what kind of equation? A linear equation. What do these look like? Exponential. Yeah, so basically arithmetic series and sequences are another way of writing a linear function. And then geometric series and sequences are another way of writing exponential functions. So pretty cool connection there. Last example, and this is the most time consuming. And again, I did not give you enough space. So we're going to write really small. And I'm going to try and keep my work organized, but it was a bit of a mess last hour. We'll see. So this is going to be the hardest thing I asked you to do. It's where you're given 2 random terms in a sequence, and you need to find the rule. So again, our general rule is a sub n equals our first term times r to the n minus 1. And now, unfortunately, we don't have a1 and we don't have r. And we don't even have like consecutive terms where we can easily figure out what r might be. So similar to yesterday, we are going to take these 2 and we're going to make 2 different equations. Unlike yesterday, we don't have a system of equations where we can just add or subtract. but I'll show you what we're going to do. So let's start with this a sub 3. So I'm going to start with a sub 3 equal to my a1 times r, and then it'll be to the 3 minus 1. So if I plug in a sub 3 is negative 48 equals a1 times r to the second. So there's my equation 1. My second equation, I'll have my a sub 6, my sixth term, a1 times r to the 6 minus 1. Well, a6 is actually 3072 equals my a1 times r to the 5th. Okay, now we can't just add or subtract here because these are being multiplied, so things don't cancel out like that. They're not even like terms. This actually reminds me of, I think this was at the end of chapter 4. Do you remember the power rules and the exponential rules where you had to like plug in? So it was like you had y equals a times b to the x, or you had y equals a times x to the b. Remember those? When we had to plug stuff in. This is what this reminds me of. We're just gonna like be plugging things in back and forth. So your first step, what you want to do is we are going to solve here for a1. So solve for a1. So to solve for a1, I would just divide both sides by r squared. So I'm going to have that a1 equals negative 48 over r squared. Once I have that, I have a1 equals this whole thing. I'm going to take this whole thing and I'm going to plug it into the a1 in my example, or in my equation 2. Plug a1 into equation 2. Then that will give me 3072 equals, here now it would be negative 48 over r squared times r to the 5th. Now, technically, it's r to the 5th divided by r squared. What happens when you divide two powers? Subtract the exponents, yeah. So what is my power on r actually? Yeah, so I have 3072 equals negative 48 r to the 3rd. Then what?
We divide both sides by negative 48.
Yep, we're going to divide and then take, yeah. So when you divide here, you'll have negative 64 equals r to the 3rd. And then like Aubrey just said, we're going to take a cube root of both sides. And we end up getting r equal to negative 4. And again, I totally didn't leave enough room, so I'm going to circle this so we don't lose it. Okay, I have my r now. Now I need my a1. How could I get my a1? Yeah, so we actually already solved for a1 up here. So now let's do this again. We're just going to take this back up here and we're going to plug it in. So I'm going to have, sorry, where do I even put this? A1 equals negative 48 over, now it'll be negative 4 to the second. What is negative 4 to the second? And what is your calculator going to tell you it is? What a mean calculator. So yeah, let's remember it's positive. So you should end up with, and I'll just jump to the answer here. So 48 divided by 16 should end up with negative 3. All right, now we have our A1, we have our R. Whew, we're good to go. So after all that work, we get to say that A sub n is equal to negative 3 times our R, which is negative 4, raised to the n minus 1. Oops, you can't see it. There we go. All right, so that's a bit of a process, but are there any questions? Kate's frowning because my messy work is all over the place. Follow my brain. Follow what happened here.
I think it's just a lot.
It is. It's a lot of like back and forth, which you guys have done before. We did that when we solved for those power and exponentials. But yeah, we have to practice this again. So the last 4 problems on your homework look like this. So you guys can go ahead and get started.